This lesson is 3.1, 3.2, and 3.3, Part 1. The first thing we'll talk about is a transversal, which is the name for a single line that crosses two or more coplanar lines. So in our picture, line T here is a transversal to lines P and Q. Anything between the two lines is considered the interior, and anything outside of those two lines is considered the exterior. So if I box off these two lines, any angles happening inside are interior angles, like 3, 4, 5, and 6, and anything outside these lines are the exterior, like 1, 2, 7, and 8. There are additional angle relationships that we can name based on the location of the angles. The first one being corresponding. I like to call this corresponding because we are talking about angles that are in the same position. And if I imagine that there is a car here and a car here, right, here's our little headlights. Angle 1 is in the driver's seat of this car. Angle 6 is in the driver's seat of this car. So angle 1 and angle 6 are in the same seat in the car, so they are corresponding angles. So another example here, if you looked at maybe the person behind the passenger was angle 3, the person behind the passenger was angle 8. So that's another pair of corresponding angles. Alternate interior angles. So now we're going to focus only on the angles inside. That means we're not using any of the angles that were considered exterior angles. And it says angles in the interior on alternate sides of the transversal. So if I picked angle 4, I'm looking for another angle inside that's not on the same side of this line. So that eliminates 6, and then I'm left with 3 and 5. We already have a name for what 3 and 4 are, right? Those are a linear pair. So we're going to really go opposite here to 5. What we're really looking at is we're always trying to relate an angle in the top car to an angle in the bottom car, so it wouldn't make sense to relate those two anyway, so that's why we're saying 4 and 5. Our other pair then, if I chose 3, would be 6. Right? Because 3 and 5 are on the same side, but 3 and 6 are on opposite sides. Alternate exterior then is very similar to alternate interior, except now we're not using any of the inside angles. So if we're choosing angle 1 from the top car, opposite side of the line would be angle 8 in the bottom car. And same idea, 2 in the top car would be the same as 7 in the bottom car. Those are alternate exterior. Same side or consecutive interior angles. So let's eliminate our exteriors. So if I chose 4, I now want the same side of the transversal. So that would be angle 6. And then another pair of same side interior would be 3 and 5. And if we have same side interior, we're also going to have same side exterior or consecutive exterior. So let's eliminate all our interior angles. So angle 1 from our top car, same side of the line as angle 7. And then angle 2 would go with angle 8. So in example 1, we want to give the best name for the pair of angles. And it does say if the lines are parallel. That's not going to matter to us yet, but it will. So angle 6 and angle 11. So they are between these two lines here. So I'm going to say they are a kind of interior, and they're on the same side of the transversal. So this is going to be consecutive interior. Let's look at 7 and 9. So 7 is here and 9 is here. They're between these two lines. And if I look at the transversal, they're on opposite sides. So that's going to be alternate interior. And I'm going to abbreviate these because once we're writing them that much, you're going to get very sick of it very fast. So then we have 2 and 15. So now they're outside of these two lines. So they're going to be a kind of exterior. And if I look at the transversal, they're on the same side of that. So this is going to be consecutive exterior. Next, we have 3 and 11. So now this is an interesting case because they're not both between the lines and they're not both outside the lines. What we have here are two angles in the same spot. They're both in our driver's seat. So these are corresponding angles. Corresponding angles are the only angles that we are learning now that are not both inside or both outside. And then our last one, 4 and 14, they're outside of these two lines, and if I look at the transversal, they're on opposite sides of it. So that's going to be alternate exterior. So this is a try problem. If you'd like to do it, pause. Answers are posted online. And now we're going to talk about what does happen if the lines are parallel. So we have 5 theorems and postulates that we're going to talk about, and all of them start with the phrase, if parallel lines are cut by a transversal. So if you have a set of lines that you know to be parallel, they have the markings or they've told you, and now we have cut it with a transversal, then the corresponding angles are congruent. That's the corresponding angle postulate. For the alternate interior angle theorem, if parallel lines are cut by a transversal, then the alternate interior angles are congruent. And the alternate exterior angle theorem, if parallel lines are cut by a transversal, then the alternate exterior angles are congruent. So anytime we have parallel lines, all 3 of these angle relationships will end up being congruent angles. And our other 2 theorems are going to be consecutive interior angle theorem and consecutive exterior angle theorem. Also starting, if parallel lines are cut by a transversal, then the consecutive interior angles are supplementary. So consecutive interior and consecutive exterior angles are supplementary or add to 180. So the only things that add to 180 are the words with a consecutive, the ones with the word consecutive, and then all the other relationships are going to be equal or congruent. So for example 2, we want to find the value of x and explain our reasoning. And our reasoning is going to be one of those postulates or theorems we just learned. So in this first one, they're between the lines, so it's going to be an interior, and they're on the same side of the transversal. So I can use the consecutive interior angle theorem, and that means they're supplementary. So I could do 8x plus 13 plus 2x plus 37 equals 180. So that's going to be 10x plus 50 is 180. 10x is 130, and x equals 13. For our second problem, they're both between the lines again, but if I look at the transversal, they're now on opposite sides. So this would use the alternate interior angle theorem, and alternate interior angles are going to be congruent, so we're going to set them equal. That's a horrible 2, but we're going to move past it. So 2x plus 36 equals 100. Subtract the 36, so 2x equals 64. And when we divide by 2, x is 32. Here's a try problem. Pause if you'd like. Answers are posted online. So now we have some phrases here that are new. Right? The end of these are not called theorem or postulate, but they're all called converse. So let me just talk for a second about a converse. Converse is the reverse of a statement. So if you had a statement like, if it is raining, the game is canceled. Oh, I'm skipping over words. If it is raining, the game is canceled. Or I should say, then the game is canceled. The reverse of that would be taking the part here and putting it in front of the if. So if the game is canceled, then it is raining. Right? We'll take the second part from here. Now, normally, it doesn't necessarily have to be true both ways, but all of the ones that we learn in this class will be. That if it works one way, it will automatically work the other way as well. So these converses all start with the angle relationship. If the blank angles are congruent, or if the blank angles are supplementary, then the lines are parallel. So we're using a different kind of theorem to prove that lines are parallel, as opposed to knowing the lines are parallel and using a theorem to prove that the angles are congruent or supplementary. So here, determine if the lines are parallel, explain your reasoning. So our reasoning would include one of those converses and possibly other things that we've learned, like the vertical angle theorem and the linear pair postulate. And that's actually going to come into play in our first one, because these two angles as they stand do not have a relationship. One's outside, one's inside, but they're not in the same seat of the car, so they're not corresponding angles. So what I would do is I would use a relationship I do know is true no matter what kind of lines we have, whether they're parallel or not. And let's say that I use the vertical angle theorem to say that this angle here is also 103 degrees. Now the two angles I'm using are both inside, and they're on the same side of the transversal. So we're looking at a pair of consecutive interior angles. And in order for the lines to be parallel, those angles would have to be supplementary. And I'm going to check 103 plus 77, I get 180. So it is true that these angles are in fact supplementary. So we can say yes, and it's because of both the vertical angle theorem and the consecutive interior angle converse. We did not have to do it this way. I could have used a linear pair instead. I could have used vertical with the 77, and that would change the end result. I might have a different reason as to why the lines are parallel. If I look at B, these are outside the lines, so there's some sort of exterior, and they're on the same side of the transversal, so those are consecutive exterior angles, which should also be supplementary. So if I check 124 plus 46, I only add to 170. So this is no, but it does say explain your reasoning, so I have to say why it's no, and it's not just because they added to 170, because that's not explaining enough. So I'm going to say no, the consecutive exterior angles, because that's what those are not supplementary. Right? So that's showing that I know what the relationship should have been if they were to be parallel, and saying why it is not fitting that reason. All right, the next one is a try. You could pause here if you'd like. The answers are posted online. The last kind of problems we're going to do are determine which lines are parallel based on the given information. And again, we're going to justify our answer with one of those converses. So I'm going to start with angle 1 and angle 7. And they're telling me that they're congruent. So that would mean that they would have to be alternate interior angles, alternate exterior angles, or corresponding angles, right? Because congruency only means those three. Supplementary means anything with the word consecutive in it. So they share line L. That's going to be the first thing I look for. I'm going to look for the line that they share. If they don't share a line at all, then no lines can be determined parallel based on that information. But these two do share line L, which means the remaining two lines here, A and B, are going to be the ones that are parallel. And now I'm looking, they're on opposite sides of the transversal outside of our two lines. So this would be the alternate exterior angle converse. Next problem is 8 and 14. These also share a line. They're both on line B. So we can say that the remaining two lines that are left to be parallel, L and M, are the ones that are parallel. They're between L and M, so that means it's going to be an interior, and they're on opposite sides. So that will be alternate interior angle converse. And then our last one, 4 and 9. So this time we're talking about supplementary. So we're looking for them to be some sort of consecutive relationship. They do share line A, so that means it's going to be L and M. And they are on the same side inside, so we can call this the consecutive interior angle converse. The last problem is a try. Pause it if you'd like to try it, and the answers are posted online. But that is the end of part 1 of chapter 3.